Okay, so let's take a look at substitution this time. I wrote down a definition and also some synonyms that you might find useful to understand the concept of substitution. The definition is that substitution is the replacement of the symbol with a number. By the symbol, I mean like variables. I wrote down some examples, but there could be like many more different variables that we could use in the future. Um, so substitution is you replace just a variable with a number. Let's just look at an example. Let's say I know one expression, 5a minus 4, and when a equals 3, if you know that this unknown number a is actually 3, then you can find the value of this expression. I hope that makes sense. So let's just put 3 into this expression. But just be careful about this 5 and a. A is not a digit, like I mentioned before. When you see a number is placed directly next to a letter or a variable, in this case a, it means they are being multiplied together, not just a digit. Like let's say I want to put 3 into this a, then it doesn't mean this number is 53. It means 5 times 3 minus 4. There's always multiplication going on between a number and a letter, okay? Yep, so we know this value, 50, we can calculate 50 minus 4, be careful with order of operations, then we get 11. This is substitution. You just substitute a for 3. So actually, like it's a bit interesting because it starts with an expression. When you see 5a minus 4, we have nothing to do more than that, but we know a equals 3, so kind of we made one equation, if that makes sense. Like if we know, if we put like kind of different value, let's say 5, for a, if we assign some different number for an a, then we get a different equation, different value of this expression. Like 5 times, yeah, I will just start with 5a, and then 5 times 5 minus 4 this time. It is equal to 25 minus 4, then we get 21, okay? So yeah, you just did substitution. It is pretty easy. It's not really the most hard concept to understand, but we can practice a little bit with these examples. There are values for different 5 variables this time: x, y, a, b, and n. Then we are gonna substitute these numbers, these variables for these numbers. Let's say x plus 3 is equal to, we are going to put 3 into this x, and 3 plus 3, so this is equal to 6. What about this one? 3a plus 7 plus a plus b. A equals 1, so 3 times 1 plus 7 plus 1 plus b equals 5 here, 5. So it's 10 plus 6, so we get 16. What about this one? Half times x plus a, half x plus a. So we are gonna get half times x equals 3 at this point. 3 plus 1. So it is equal to 3 half plus 1. So how to calculate this one? We have to make the same denominator 2 over 2. So we just combine those two numerators and we get 5 over 2. Similarly, 10n plus 2b, n equals 3, b equals 5. So 10 times 3 plus 2 times 5. So, yep, we do multiplications first. 30 plus 10, we get 40. Yep, this is substitution. So, these examples that we just did just all look pretty easy. There could be some problems that might confuse you. Let's just quickly go over those. Let's look at this one. When a equals -3, you want to evaluate this one. Minus 2a plus 7. Yep, let's see this one. Be careful when you substitute a for my -3. How do we write this one? I will show you. Brackets will help you a lot, like in this situation. -2 minus 3 plus 7. So this is completely different from this one. So do be careful. This is just -9, while this one is just 9. How so? Because if you write -3 squared the whole thing, then this basically means -3 times -3, and those negatives cancel, and you can just get 9. While the second one, -3 squared, means just -3 times 3. Maybe I can put bracket here. So this is equal to -9. So yeah, it's something that you should know when you do substitution. Yeah, let's just evaluate this equation. So this will become 9, and -2 times -3. Also, we have two negatives again, so this will become positive. Plus 6, 2 times 3 equals 6, plus 7. So this is equal to 15 plus 7, so 22. So maybe one more. Yeah, let's just do one more thing. When a equals half, then how do we evaluate this expression? Just same expression that we just did. Let's see. So pretty much the same. It is better to put brackets just to make it easier. 2 times half plus 7. So this will become quarter. Sorry, this is not a negative. Quarter, because half times half. So you can just simply 2 times 2 equals 4. So quarter minus 1, because 2 times half equals 1 plus 7. So quarter plus 6. 6 equals 24 over 4. So that's how we get 25 over 4. Okay, I think that's enough for substitution. Let's move on to expand and simplify basic algebraic expressions. But before we go any further, we have to quickly learn what like terms are. Like terms. So let's say you have an apple and you get another apple. That basically means you have 2 apples. But if you say have 1 apple and 1 orange, you can't really add them together, you know? You can't simplify further than that. It's just one apple and one orange. This is what like terms are all about. Let's say you have one A and you have another A, then it will make two A's. But if you say you have one A and you have a B, then it's just A plus B. So what happened? If you see this one, you kind of combine those two like same variables. Those two, A and A, yeah. You're just those two have the same variable, and so you can add them or subtract them. Let's see some more examples to make things easier. Let's see this one. 2a plus 7 plus 3a plus b plus 3. Let's see this expression. When you think about 2a, we have done this a lot of times. There's multiplication going on between this number and this variable. So this is basically 2 times a. But when you think about the definition of multiplication, this actually means a plus a. Same goes for 3a. It means a plus a plus a. So now we are trying to add them. That basically means we are going to get 5a, right? So these two, we can add these two, and then these two as well. These two are like terms. So what do we get? 2a plus 3a, 5a plus b plus 10. But you might be confused about the power. When we talk about like terms, they have to be the same variable, but also raised to the same power. Let's say a squared plus a plus 3a squared plus 4a. For this expression, you might want to think that these two are the same and also these two are the same. Because like I said, this is just a squared, but this is a squared plus a squared plus a squared. So if you add them, then you will get 4a squared. What about these two? Yeah, these two are 5a. So this will be equal to 4a squared plus 5a. Also, we might come across some other forms, like other kinds of form, like xy. So this basically means x times y. If we see 3x times y plus x plus y, then you can't really simplify further than this one. Because xy is different from x, xy is different from y. Yeah, so that's why. Yeah. So if you see like 4xy here, then you can see those two are like terms. But that's it. Not x or not y. Yeah.